All right, it's Mr. Gamache again. Let's get rolling here. We're going to talk about bias and bad sampling today. So we ended the last video where I was talking about one type of bad sample, so we're going to review that, and then we're going to talk about another type of bad sample, and then we're going to talk about some bias, which can really play into your statistics, so you want to be careful of that. All right, the first type of sample we talked about yesterday, the bad sample, we ended with this, was a convenience sample. And just a reminder, a sample is what we do when we want to know something about a population, but there's just too many individuals to get to. We can't ask everybody, we can't check every individual item. So if that's the case, that's when we do a sample. And we want our samples to be random, and we want to give every individual the same chance of being selected. Now, the thing with the convenience sample, it's exactly what it sounds like. It's when you're doing a sample, or well, let's say collecting data from, we'll say, individuals easiest to access. All right, so an example of this is, say we're here at Grafton High School, right? You want to do a sample of Grafton High School students, and you say, all right, I want to do a sample of Grafton High School students. Can't ask everybody, so I'm going to do a sample. So then you look around your classroom and say, all right, I'm just going to ask everybody here, and then I'm going to assume that's the opinion of Grafton High School. That's a convenience sample, because guess what? It was really convenient for you because you never even had to leave your room. You just had to basically look around, maybe even get up from your seat. You just yelled, hey, who has blue eyes? There you go. So you don't want to do a convenience sample. Why? Because everybody else has no chance of getting selected for your sample. If you're just asking the people in your class, maybe you're a freshman. That means no sophomores, juniors, or seniors had any chance of being asked. You don't want that to happen, so convenience samples are bad. You want to avoid those. There's another type of sample I wanted to throw in here. Some textbooks cover this, some don't. I think it's a good one to talk about because, unfortunately, some people see this next sample and they think it's a great idea. It's not. This is what's called a systematic sample. What is a systematic sample? That's when you select every nth individual. What do I mean by that? All right, say again, you want to do a survey of, let's say, Grafton High School. Let's stick with it. It's nice and easy. All right, so you say, I want to do a sample of all Grafton High School students. So I'm going to stand at the entrance. I'm going to start at 7 o'clock in the morning before anyone gets here because you decide you want to do this really well. Maybe even take out your random number generator. Say, okay, I'm going to randomly select a number, 10. I'm going to ask every 10th kid whether they have blue eyes or not. So you sit there at the door, you go 1, 2, 3, 4, 5, 6, 7, 8, 9, not asking them. 10th comes in, you ask them. Wait for another 9 to go by to ignore, you ask the next 10th person to come in, and so on. That might seem pretty good to you because you're like, hey, I randomly selected the number 10, so I'm in pretty good shape. But guess what? Those first 9 individuals who are walking in, they have no chance of being selected. Likewise, for the next 9 who come in after the one you select. So by doing a systematic sample, you're actually systematically excluding people from your sample. You don't want to do that. You want a sample that's going to offer you and everybody the same chance of being selected. So that's why we want to avoid a systematic sample. Convenient sample, systematic samples, bad. So I'm going to even shrink down systematic sample. And I'm going to go down here, and I'm going to call this bad samples. Why? Not every individual has the same chance of being selected. Let's take it further. Like we started talking about Apple and iPhones yesterday. All right, Apple's got millions of iPhones, ready to ship out. And someone alerts them, one of the engineers, and says, hey, there might be a problem with the phones. We're not sure. You don't want to open up millions upon millions of phones to check to see if they all have problems or even if some of them have problems. So maybe you decide to do a sample. Remember, comedian sample, maybe that's like, I'll just check the box in front of me, see what's going on. Check the box in front of you, maybe it looks good, but that means the rest of the phones could have issues. So that's not good. A systematic sample might be, all right, I'm going to check every 100th phone and I'll see if there's something wrong with it. Guess what? Those other 99 that you're ignoring, they have no chance of being selected because of that. And that's not good. That's not representative of your population. So again, these are bad samples. You want to avoid these when possible. Even if there is some randomness involved, they're still bad. You want to give every individual within your population the same chance of being selected. And if possible, every group the same chance of being selected. That's why I generally like simple random samples, but you'll find, like as we talked about in the previous video, stratified samples can be good, cluster samples can be good. But again, these are the bad samples. Avoid these. All right, now we're going to talk about a term that you've probably heard before, probably heard people use this, and we're going to talk about what it means in the context of statistics and the different types. We're going to talk about bias. Now, you might have read articles, where you said, oh, it looks like this reporter has a bias. Maybe you're watching the television news and you're like, oh, it seems like they're biased. They're favoring one person over the other, or they're favoring one side of the story to the other. So you have maybe some perspective of bias. Now, what bias is it causes you to overestimate or underestimate your population. We'll talk about what that means in context a little bit. But basically, it's when you do something that causes you to come up with a bad statistic that doesn't necessarily represent your population. We'll talk about different types of bias that can lead you there, which will help you a little bit. First one we'll talk about is undercoverage bias. This happens a lot, believe it or not. You can even argue that it happens a lot with election polling. At least it used to. Now, undercoverage bias is when your sample underrepresents a portion of your population. So let's take this in the context of Grafton High School. You decide, all right, I want to do a random sample of Grafton High School students. I have a great idea. I'm going to wait out by the bus stop, right where the bus, drops everybody off in the morning. I'm going to stand out there. I'm going to do a really good random sample. I'm going to randomly select numbers and say, I'm going to talk to the 15th kid, the 40th kid, the 72nd kid. You got all these random numbers. You think you're off to a great start. However, you're suffering from undercoverage bias. Why is that? Not everybody takes the bus. You're systematically excluding people who might drive to school, people who walk to school, maybe people who come in late. That's undercoverage bias. When you're specifically, ignoring a portion of your population that could be important and that could ultimately affect your statistic. Another example would be with elections, right? A lot of times they do polls. How they do these polls? A lot of times they call landlines. Remember landlines? Yeah, okay, I'm dating myself a little bit. But those are the phones you used to plug into your wall. Maybe some of you still have them. And the phone rings. I don't know what it's like at your house, but at my house, when we had a landline, if you heard the phone ring, you check caller ID. If you didn't recognize the number, you wouldn't pick up. Believe it or not, pollsters used to rely on landlines big time. They would randomly call people at home and then, ask them to do a survey. And guess what? If you're doing that, if you're just calling landlines, that's undercoverage because guess what? You're not representing people who don't have a landline. That's important. That could be a big portion of your population. So when you're doing a sample, when you're doing a survey, you want to make sure that you're representing your whole population. You want to make sure people aren't getting excluded. When pieces of your population, specific groups of your population are getting excluded, that's what's called undercoverage bias, and you want to be careful of that. Another one, which kind of touches on one I just mentioned, undercoverage bias. Oh, I just talked about that. Whoops, that's all right. We're going to talk about non-response bias. Excuse me. Now, non-response bias. This is when people or individuals have the option to not respond. Now here's something you can come back with too. Say you decided, okay, I'm going to randomly call phone numbers, not just landlines, cell phones. I guess technically it could be under coverage bias because you're dealing with, well, what about the people who don't own phones? Let's go under the assumption that everybody owns a phone, all right? We know everybody has a phone. They have some sort of phone number, okay? So you randomly call like 100 randomly generated numbers. You call them. Guess what? People have the option to not pick up that phone. That gives you possibility non-response bias. They have the chance that they have their choice that they don't have to answer, they don't have to respond. That could lead you to say like, okay, well, chances are you're going to hear from people who really are passionate about this. Like a non-response bias. Another example of that would be, say like on the news, sometimes they do this. They'll do a poll. Right? At the end of the news, oh boy, I'm even dating myself. Who watches the news anymore? But say you're watching the news, or even you look online. Heck, they have polls about that. They'll have a poll like, how do you feel about this? Like, were you impressed with Cam Newton's performance this weekend? Yes or no? Non-response bias. Why? Because people have the option not to respond or not. If you're kind of on the fence, or you don't really feel passionately one way or the other, you're probably not going to respond to it. With non-response bias, you tend to get responses from people, I'm even going to put that, tend to get responses from people who are passionate. Get responses from only people who are passionate. About one choice or the other. Now, another example of this, like say you're going online. You see a poll. And it has to do with gun control. It says, do you believe that there should be firmer gun laws? Chances are you're going to be hearing from people who are like, guns are bad, we don't want any guns, period. So they're going to say, yeah, we need further gun control. Yes, 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 yes. Or you might hear from people who are very firm saying, no, 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 I want my right to bear arms. You're not going to get a lot of people who are kind of in the middle like, I guess, go either way, especially if they have the option to not respond or not. If you're not passionate about something, chances are you're not going to participate unless you really have to. That's what you're looking at here with non-response bias. And then we got one more we're going to talk about, and this is what's called response bias. Wait a second, we just talked about non-response. You're saying response can give a bias? Let me explain. And you're going to understand as soon as I tell you. Say I wanted to do a random sample to figure out what percentage of students think my instruction's, going well this year. So, I randomly select kids from my list of all my students. I randomly select 20 kids. I sit them down at my desk. I say, so, how do you think I'm teaching this year? All the kids look at me and say, I think you're doing a great job. Why? They might be a bit intimidated by me, even though hopefully they aren't. But maybe they don't want to hurt my feelings. That's another case. That's response bias. It's when you can get untruthful responses for one thing, for one reason or another. Maybe they just don't want to look bad. Maybe they don't want to hurt my feelings. So you get untruthful answers. Or it also has to do with poorly worded questions. What do I mean by that? Say, all right, let me think of one here. We'll go back to gun control. I know it's a little touchy, but I'm not taking one stance one way or the other. But say I go up to people and say, seeing as how, guns are responsible for 87% of deaths in the United States, do you think we should have firmer gun control? When people hear that preceding statement, they're going to be like, oh my gosh, Guns are responsible for 87% of deaths in the United States. Heck yeah, we should have further gun control. Here's the thing. I led you to an answer. I kind of threw something in there to kind of sway you one way or the other. That would be an example of response bias because I'm poorly wording a question. When you're asking a question, you don't want to include language that's going to lean someone one way or the other. So that's something you want to watch out for too. And now, or another way I could do it too is say a kid decides to randomly say, how effective is Mr. Gamash's teaching? Not me. I'm not going to ask someone. Some student that randomly decides to do it. So I go up to kids and saying, seeing as how it's Mr. Gamash is, he's an awful teacher. I heard kids think he's awful. Are you looking forward to having him next year? They're going to say, no, you told me he's awful. Again, you're using some sort of leading in there. You're trying to sway them one way or the other. That would be an example of response bias. So response bias is when you're presenting a question, like maybe it's the person asking it that could lead to an untruthful answer, or maybe it's the way you're asking that question. Maybe it's poorly worded and it's going to sway someone one way or the other. And that's what you're looking at with response bias. So when you're doing a sample, you want to watch out for these things. You want to watch out for, again, undercoverage bias. You want to make sure you're accurately representing your population. You don't want to exclude anybody. Don't actively exclude anybody. Make sure you're being good about it. For non-response bias, make sure, if possible, try to make sure that you're going to be getting, some sort of sample where people don't have the option to not participate. You want to make sure that they have the option to that everyone can participate and that they're not going to choose one way or the other. Because you don't want to just get people who are passionate one way or the other. You want to create some sort of sample where non-response isn't going to come into play. And you also want to watch out for that response bias, where maybe you don't want to lead them in the questioning. You don't want to use language that's going to lead them to one answer to the other. Again, this happens a lot these days. You'll find stuff online or maybe even in the news. That's why people say, they're biased. Because you know what? They're using language to try to lead you one way or the other, to kind of lead you to their viewpoint. That's where that word bias comes in. That's something you want to watch out for. Like a response bias, I guess another example of that would be is if you're watching the news and they're talking about, hey, we got the presidential election coming up. They talk about 5 minutes for about what an awful person our president is. They say, he's awful. He's doing all these things wrong. And then at the end of it, they say, so are you supporting him for president? Guess what? There's some bias there because they weren't being objective. They're throwing all this stuff at you saying, he's awful. And then they're leading you to an answer. That's bad. And again, untruthful answers. That might be an example as if our president goes up to people literally and says, how do you think I'm doing? Now, some people might be bold enough to say, I think you're doing an awful job. But chances are, a lot of people aren't going to have the courage to say, I think you really need to step it up and change things. That's not going to happen. That's what you want to watch out for. So response bias is, again, untruthful answers. Maybe it's who's asking the question. It's very common. And poorly worded questions that might lead you to an answer or not. So you want to be careful of bias too. When we do good samples, we want to make sure it represents our population. So when we do that, we want to make sure it's random. And not just, random like a systematic sample where we randomly select who we're going to ask every 10th person. You want to give, every individual the same chance of being selected. That's important. You want to have that chance that you can literally ask anybody, and that's going to accurately represent your population. Hopefully this helps you as you're learning about samples.